Hi, this is Mrs. LaBarbara. This is AP Physics Mechanics C. Today, we're going to talk about a question that has a combination of many concepts: rotation, energy, and projectile. This is a question from past AP exam. So a large sphere rolls without slipping across a horizontal surface. The sphere has a constant translational speed of 10 meters per second, a mass m of 25 kilograms, and a radius r of 0.2 meter. The moment of inertia of the sphere about its center of mass is I equals 2/5 mr squared. The sphere approaches the 25 incline of height 3 meters as shown, and rolls up the incline without slipping. First, you need to calculate total kinetic energy of the sphere as it rolls along the horizontal surface. So we know the sphere is rolling along, and also the center is moving in the horizontal direction. So here's the kinetic energy has two parts, the rotation and the translation. So we need to add the two. Rotation is 1/2 I omega squared, and translation is 1/2 mv squared. Now I equals 2/5 mr squared. Omega and r are related by this equation. Omega equals v over r, because this is rolling without slipping. Now if we put everything in this equation, you will have K total. The total kinetic energy equals to 7/10 mv squared. So this is the equation for total kinetic energy for a ball, a solid sphere, rolling and without slipping. Now in order to find total energy, we simply substitute the numbers, and you should have 1750 joules. Part B. Okay, first one, calculate magnitude of sphere's velocity just as it leaves the top of the incline. So at the top of the incline, so as the ball goes up, it's going to roll, and the speed is going to increase. The speed is going to decrease, so its omega is going to decrease, because part of the kinetic energy is changed into gravitational potential energy. So total energy at the top is just gravitation plus the kinetic. Kinetic, because it's rolling without slipping, the kinetic energy is 7/10 mv squared. That's the part we got before. And from here, we can substitute all the numbers and solve for V. E total is just the energy from before. So you should have V equals 7.56 meters per second. Part 2 of B, specify the direction of sphere's velocity just as it leaves the top of the incline. So as the ball comes up here, it's going like a projectile launched in that way parallel to the incline. So the direction should be parallel to the incline at 25 degrees above the horizontal. Next one, neglect the air resistance. Calculate the horizontal distance from the point where the sphere leaves the incline to the point where the sphere strikes the level surface. So here is the ball right over here. It's going to be launched as a projectile falls down. You are asked to find x. So in this question, it's two-dimensional motion. I'm going to say to the right is positive and going down as positive, because it's most convenient for my calculations. So to find horizontal distance, we use this equation because horizontal acceleration equals to 0. So we just have to find initial horizontal speed, and we have to find the total time of landing. The horizontal speed is just VI cosine theta. We know VI from last question, 7.56, and theta is 25 degrees. It's given to us. So from here, we can find VI 6.85. Now we have to find T. To find T, we have to use the vertical parameters. So what do we know is VIY. VIY is negative VI sine theta. Why is it negative? Because I have defined down as positive. So at this point, when it's just leaving the incline, it's going upward. So its initial velocity is upward, therefore it's negative. I substitute 7.56 times sine 25. I will get negative 3.19 meters per second. Now, in order to find the time, you can plug this into quadratic equation, or you can use the other way. You can find a final velocity of the ball, because I know the initial velocity, I know the acceleration, in this case is positive 9.8 because it's going downward. I know the displacement is positive because it's going downward, so you can find final velocity. Final velocity is 8.31 meters per second. VIY again is 3.19. It's negative, squared still is positive. So this is positive number because it's downward. Now I have the final velocity, I have initial velocity, I know acceleration, I can find time using this equation. Remember, initial is negative, you need to substitute the negative value in there. I have 1.17 seconds. Now I have the initial horizontal velocity, I know the total time, I can find horizontal distance by plug that in to this equation. 6.85 times 1.17, my horizontal distance is 8.02 meters. Part D. Suppose instead that a sphere were to roll toward the incline as stated above, but incline were frictionless. State whether the speed of the sphere just as it leaves the top of the incline would be less than, equals to, or greater than the speed calculated in the previous part. So calculating the previous part is 7.56. That's what we calculated. Now what would this be if there is no friction? If there were no friction, the rotational energy, 1/2 I omega squared, is not going to change into into potential energy. So if the incline were frictionless, only the translational kinetic energy, 1/2 mv squared, is going to be converted into potential energy. The rotational kinetic energy, 1/2 I omega squared, that would stay the same over here as it was on the horizontal surface. So because the only v decreases, omega doesn't decrease, this is rolling with slipping, so that v does not equals r times omega anymore. Omega is bigger than that. So in that case, because the speed part, translational speed, changes to the potential energy, so the speed would decrease. You can calculate it actually. So only the translational kinetic energy changed into mgh. So from here you can find Vf equals to 6.42. Originally, when you have friction, is 7.56. So you can see the speed has decreased. Okay, that's it for today. Thank you for watching. See you next time.